In this video, we're going to graph polynomial functions. So for each function, we're going to write the end behavior, calculate the zeros, and state each multiplicity, and graph the function. Now, before we can write the end behavior, I need to know the degree, which in this case is 5 to 3 plus 2, and the leading coefficient is positive. Now that I know those two pieces of information, I can write out the end behavior. So as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches infinity. Okay, my zeros. Because I have a factor of x minus 3, the zero is 3 with a multiplicity of 2. Because the multiplicity is an even number, it's going to kiss and go in the opposite direction. The other zero is negative 1 with multiplicity 3. Since the multiplicity is odd, it will cross there. Okay, so now then, I know all this information. Let's graph this function. So again, I'll start with the zeros. Okay. And again, using my end behavior, and that it crosses at negative 1, kisses at 3. Okay. There is a sketch of my polynomial function. All right, let's take a look at Desmos then and compare. Again, notice end behavior matches similarly to mine. Okay. Okay, so now let's take a look at another function. Again, two very important things. Number one is going to be the degree, and number two about the leading coefficient. Well, the degree. Don't forget about this 1 plus 3 plus 4 plus 2, that is 10. And the leading coefficient is positive. Well, that's easy to be able to write the end behavior then. As x approaches negative infinity, g of x approaches positive infinity. As x approaches positive infinity, g of x is also going to approach positive infinity. Okay, the zeros. Well, the x represents a 0, multiplicity 1. So at 0, it will cross, because multiplicity is odd. 1, multiplicity of 3. That will also cross. Negative 2 with a multiplicity of 4, it will kiss. And 8 with a multiplicity of 2, that will kiss. Okay, so now I have all my information for this. I'm going to start graphing. So let's do the zeros first. Okay, so we know it's coming down. Let's see, at negative 2, I'm going to kiss and go in the other direction. Okay. At 0, I will cross. At 1, I will cross. And at 8, I'm going to kiss and go in the other direction. Okay. So that gives me at least a rough sketch of what this graph is going to look like. Okay, now let's take a look at Desmos to see what this would look like. Okay, so I'm going to get rid of this graph and put this one in. And again, you can tell the kissing, crossing, crossing, and the small amount of kissing very similar to my particular graph for it. Of course, Desmos does it a little bit better. Okay, so now let's take a look at a third one then. All right, so this one we're going to have to do a little bit more work for the zeros. But again, we should be able to tell the degree quickly. Now, notice, the terms are separated by addition and subtraction. So the degree is not 6 here. The degree is 4. And the leading coefficient is negative because the negative that's in front of the term x to the 4th. All right, end behavior. As x approaches negative infinity, h of x approaches negative infinity, as x approaches positive infinity, h of x still approaches negative infinity. Okay, zeros. Okay, so I'm going to set this h of x equal to 0. Factor out an x squared, and I'm going to make it negative. So I'm left with x squared minus 8. Okay. All right, so I'm going to set each of these equal to 0. So divide, and we know that's going to be 0. So that is 0 with a multiplicity of 2. Again, because the multiplicity is even, it will kiss. Now, here I have 8 is equal to x squared. This is plus or minus the square root of 8 is equal to x. Now, below I will simplify. That's 2 times the square root of 2. That's the multiplicity of 1. So I will cross. And negative 2 times the square root of 2 with a multiplicity of 1. I will cross there also. Okay. Now, keep in mind the 2 times square root of 2 is approximately 2.8. So negative 2 times square root of 2 is approximately negative 2 and 8/10. Okay, so now that I have all my information for this, I can graph. So again, I'll start with the zeros. Okay. So we know they're both coming down, and we're going to cross. Okay. We will kiss and go in the other direction at 0, and then cross at 2 times square root of 2. Now notice this function is even, meaning it is symmetrical across the h of x axes. Okay, okay, so let's take a look then at the Desmos graph. Get rid of this. And again, other than the fact it went a little bit higher than mine, you can see it's the same similar type of graph for this. Okay, our last example I would like to do then is I'm going to use the graph below to answer the questions. Okay. All right, so first of all, we want to list the real zeros and state its smallest possible multiplicity. So let's list out the zeros first. Okay, so let's scroll down. So we got what? 1 0 at negative 4. Okay. We have a 0 at 1. And we have a 0 at 3. Now, because at negative 4 and at 1 and at 3 they're all crossing, we know the multiplicity has to be odd. So the smallest odd number that I can use here is 1. So each one of these will have a multiplicity of 1. Now, if it was kissing, then the smallest number I could use there, not 0, 2. Okay, but we don't have that in this case. Okay. All right, is the degree even or odd? Well, a couple of things we could say. We know it's odd. Okay, either we can use the answer for part A and add up 1 plus 1 plus 1 is 3, or we know the end behavior directions are going in opposite directions. Okay, that's how we know it's odd. Now, the next part asks if the leading coefficient is positive or negative. Now, remember, if x is approaching negative infinity and f of x is approaching negative infinity, and as x approaches positive infinity, f of x is also going to positive infinity, we know that the leading coefficient is going to be positive. Okay? So now I want to be able to write an equation for the polynomial function. Okay? Now, I will write it both as an equation and as a function equation. Let's start with the equation, though. Okay, we'll do y equal to. Now, what do we know? The 0 is negative 4, so the factor is x plus 4. We know the 0 is 1, so the factor is x minus 1. We know the 0 is 3, so the factor is x minus 3. If I wanted to write this as a polynomial function equation, I might just replace y with f of x.